Hi everyone. The purpose of this video is to see an alternate way of finding all of these binomial coefficients. That's what these things are called. So for that, we define a process through which we can make something called a Pascal's triangle. The process is iterative. So let's do it. We go 1, right? Now we start with 1. And then once you write this 1, there's like two spaces created. There's something to the left and to the right. So we have, whenever I say empty space, that's what I will refer to. So what we do is for each of these space, we look at what's above and add. So right here, the only thing above this is 1. And only thing above this is 1. So that gives me the second row. Now, when I'm here, only thing above me is 1. But over here, what's above me is 1 plus 1. So this is 2. And then a 1. And then I keep doing this. So I have 1, 1 plus 2, 3, 2 plus 1, 3, 1. 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, then 1. Then 1, 1 plus 4, 5, 10, 10, 5, 1. So you get the idea. It goes 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, 1, so on. It goes on. Now, a few things that I want you to take note of here is, remember what we had, x plus y, right? X squared plus 2x plus y squared. X cubed plus 3x squared y plus 3xy squared plus y cubed. And then in the previous two examples, we saw these numbers, 4, 6, 4, and the 5, 10, 10, 5, for which we made the comment, well, if we knew, we would have to do half the calculations. So what this means is this triangle as constructed is actually giving me these numbers which I'm interested in, which are the binomial coefficients. So if I construct this triangle, I have to just be careful that I use the correct one, right? So this is, say, this is row 1, row 2, row 3. So if I'm doing raising it to the power n, then I'm looking at n plus 1th row, right? So if I'm looking, and then I can go across and I can actually pick which coefficient, right? So let's use this triangle for x plus y to the 6. 6 means I look at the 7th row. So that's 1, 2, 3, 4, 5, 6, 7. That is my 7th row. Once I have my 7th row, all I have to do is, the first and the last is always 1 and it's 6. So it's 6. Now the power of x is going to reduce and y is going to increase, right? So let me write that out first. 4y squared, x cubed, y cubed, x squared, y 4, x, y 5, y 6. And then I copy these coefficients. So I have 1 and then a 6 and then a 15, a 20, a 15, a 6, and then a 1. So that is going to be just using the triangle. So much faster. Similarly, 2x plus 1 to the 10. Now this is going to be messy. So 10 means 11th row, right? So I need to build more of these because that's 8. So that's going to be 1, 8, 28, 56, 70, 56, 28, 8, 1. That's 8, 9th row, 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. Lastly, 110, 45, 120, 210, 252, 210, 120, 45, 10, 1. So that's my 10th row. Okay, 7, 8, 7th, 8th, 9th, 10th. Oh, I'm so sorry. I didn't need to do that. The 10th row is over here. Forgot how to count. That's the 10th row. Oh, but we're finding 10th. Oh, disaster. We're finding power 10, so it has to be the 11th row. So I did do what was needed. Okay, so first I'm going to write down the terms without the coefficients, right? So I'm going to have a 2x to the 10. Now here things get, I mean, they are complicated because it's power 10, but thankfully one thing is nice, which is this is a 1, which means 1 raised to any power is 1, so we don't have to worry about that. All I have to keep doing is I have to keep reducing the power of the first term. So 2x 8, then I have 2x 7, then I have 2x 6, then I have 2x 5, 2x 4, 2x 3, 2x squared, and then 2x. And then I just have to copy these coefficients down. So I have 1, then I have a 10, a 45, a 120, 252, oh sorry, 210, 210, 252, and repeat 210, 120, 45, 10, and then actually a 1, so plus 1, because the last one is going to be 1 raised to power 10, which is 10. So that is using the Pascal's triangle. And the only thing, well, okay, unless the question says, write out, which it will not, you just have to, it's okay to leave it like here. So I don't want you to calculate 10 powers of 2. You won't be dealing with very high powers, maybe right up to 10, in which case you can just leave it right here. So as you can see, we're building up. We had foiling, and then we had the binomial coefficient, and now we have this triangle. So things get a little easier once, if you find patterns, and then you are able to solidify those patterns into something provable, which is basically all of math. So it's finding patterns. All right, that's it for this week, and that's the end of all the videos for the course. Okay, thank you everyone.